Alright, so now we're moving into 2.7 and graphing techniques. Really the key to doing these problems is knowing your basic shapes for the functions. Most of them are displayed at some point in the chapter, but the ones that you should know the basic shape for would be the absolute value of x, which looks like a v, the function y equals x squared, which is a parabola, looks like a u, and then x cubed, which looks kind of like an s. So again, scan through your book, make sure that you have a basic understanding as to what all those graphs look like, because it can really help with this chapter, or this section, as it were. So with this one, you don't necessarily have to find 3 points on this graph. You can if you want, but it's actually more time consuming than using these translation and shift techniques, which they're all summed up at the bottom of page 252. I do recommend reading through the entire section, but if this looks familiar to you, you may just want to refresh your memory by looking over those rules. So, I'm looking at number 59, which is y equals negative x plus 1 cubed. Okay, so the trick again to these is identifying what your original function was, and that you can usually tell from that exponent. So since that's a cubed, my original function was the x cubed, which again is shaped roughly like an s. So now you just have to look through and identify your rules. Okay, so for this one, we have a negative sign that's out in front of the function. So for that one, we're going to do a reflection across the x-axis. That's rule number 7. So there's going to be a reflection across x. And then the other thing that we're going to do, so there's a shift in here. Now we just have to determine whether it's a horizontal or a vertical shift. So if it is included inside the function that's being, obviously, if you're using a horizontal, or I'm sorry, I can talk. If you're looking at an absolute value function, if you had something like this versus something like, I'm sorry, that should be a minus. I'm going to keep my example consistent. Alright, so if you had this type of example, this 2 is on the inside, it's included within the function. This one is on the outside, and that determines whether it's a vertical shift or a horizontal shift. Now, since this one is on the inside, we're looking at a horizontal shift, and since this is positive, it goes to the left. It's sort of the opposite of what you would expect for horizontal shifts. For vertical shifts, if it's negative, it goes down. If it's positive, it goes up. But for horizontal, it's the opposite of this sign. So since this is positive, our graph is going to get shifted 1 unit to the left. So we've got a shift 1 unit to the left. Okay. So again, it might help you out to draw your original graph, what the original shape looks like on here, maybe using a dotted line so it's obvious which one is the real thing and which one is not. So again, this one looks like an S, goes through the origin, and then back up again. And again, I'm not super picky about this. You don't have to be ultra precise. So what this is saying is we're going to shift this 1 unit over this way. So this point is now going to be here. And this point would now be over here. And again, it may help you to do each one of these things that needs to happen in stages. I don't know why I started with this one. I didn't have to. But it may help you see what's going on a little better if you do it one at a time. So if I do my shift, my new graph now would be 1 unit over. And now, lastly, I have to do this reflection across the x-axis. So any point that's down here, I go a corresponding distance above the x-axis. So this point is now up here. This point stays where it is because it's already on the x-axis. let's see, where am I? And then this point would go down here, and so on and so forth. So now my graph, if I do a couple more, so this point, that's 3 units above, so this would be 3 units below. This one over here, that one is 3 units below, so roughly right there. Okay, and then this is my actual, I've done both of my transformations now, so I'm going to go ahead and draw my curve in. This is the real thing. So it curves in, oops, can't see what my hinge is doing, across, and up and down. Okay, now again, that's not very precise, but I'm not asking you to be precise on this one. If I was, I would ask you to graph points. But this is all about being able to understand what these different transformations do and how they work, less so than precision. I'll do another one, but please let me know if you have any questions.